OK，同学，欢迎回到来 Part Two 啊。OK，Part Two 可以看第六题，is about rate of reaction. So here, I think most likely the experiment, one of the rate of reaction experiment will be acid plus metal lah. Okay, so here it says experiment 1, 2, 3 are carried out to investigate the factor affecting the rate of reaction. So every time when we do rate of reaction, they give me a lot of set of experiments like that. I must first compare, okay, and see what is the factor that is affecting the rate of reaction. 所以是什么 factor 在影响着它的 rate of reaction? So compare experiment 1 and experiment 2. So you look at the two experiments together, you'll find out the difference, okay? Which part is different? We can see the difference is here. Hydrochloric acid and sulfuric acid. 它用不同的 acid。Hydrochloric acid 是 HCl，sulfuric acid 是 H2SO4。So 它的差别在什么？在哪里呢？它是什么 factor 呢 ？What's the factor that's affecting the rate? 1H and 2H is definitely concentration of hydrogen ion， 所以它的 concentration 不同。And then when I compare experiment 2 with experiment 3, we can see there is this extra solution. What is this? This is a catalyst. 这样子。So the graph for the 3 sets of experiment are already given here. Okay, so question A. State the factor that affect the rate of reaction. One factor, okay. So every time you write factor, factor got 4. It can be size, catalyst, concentration, and temperature. So 怎样知道有什么 factor 是可以用的嘞？ Okay, you see the reaction. This reaction is the reaction between magnesium and sulfuric acid. Okay, based on the reactant, if there is a solid, they can use size. They can 它可以换它的 size， 就是它可以通过改变 solid 固体的 size 来改变它的 rate of reaction， 它的速度。And then whenever there is a solution, they can always change the concentration or temperature to affect the rate of reaction. And then 最后 catalyst 只是用在2个东西上面，一个是 acid 加 metal， 也就是这一个 reaction， 另外一个是hydrogen peroxide， 所以它是 specific 的2个罢了。所以当他要我讲一个 factor 的时候，我已经有答案了。Concentration of catalyst. So when we are writing factor, we don't just write concentration. We must write this 这个 concentration of 什么 ？Don't forget of what? Like what I written on the top, concentration of hydrogen ions. Okay. And then if you doesn't want to write concentration of hydrogen ion in the acid, you can write presence of copper 2 sulfate solution as catalyst. OK， 所以不要只是写 don't just write catalyst， 不要只写一个字当他问你 factor 的时候，一定要讲清楚是什么东西的这个 factor。Then give a reason why the curve 2 is steeper than curve 1. So when you see curve like this, okay, you can see they are having different height, 不同的高度。So 高度是determined by the volume of gas released 的。它产生越多 gas, then 它就上越高咯。More gas, then higher 咯。Okay, for the height of the graph. And then for steepness, right? Steepness 是斜度，在最左边的是最斜的，最右边的是最不斜的。所以 the steepest one, why does it come with a steeper curve? Steeper means it has a higher reaction, higher rate of reaction. So 我写起来 steepness represent rate of reaction, and height is the amount of product. More product, higher. Higher rate of reaction, steeper. So when they ask me why is it steeper, it is because the rate of reaction in experiment 2 is higher than experiment 1. That's why it is steeper. Okay, then beside adding copper to sulfate, suggest another way to obtain curve 3 from curve 2. If the volume and concentration of sulfuric acid are unchanged, 你看，他讲他要像 catalyst 这样子去提高它的 rate of reaction. They want to increase the rate of reaction, but without using catalyst. So what are the other factors they can use? You can see the solid is already in powder form, 已经是粉状了, so there's no way we can make it smaller already. So now the last factor is temperature. So we can, when they ask me how to do it, I will tell them tell them to increase the temperature of sulfuric acid. OK， 好，这样子。OK， factor 很重要啊。OK， then next, explain why the total volume of hydrogen gas released in experiment 2 is double the volume of hydrogen gas released in experiment 1. So as we said just now, hydrochloric acid is a monoprotic acid. 它只有一个 H. While sulfuric acid is a diprotic acid. So sulfuric acid contains twice the concentration of hydrogen ions compared to hydrochloric acid. 所以它比 hydrochloric acid 多1倍的 hydrogen ion. Okay, twice, 2 times more hydrogen ion than HCl. That's why it's able to produce more hydrogen gas. Okay, and then here comes the next important question, equation. So Mg plus H2SO4 equals to MgSO4 plus H2. Make sure it is balanced. And then when they say calculate the total volume, sometimes it can be maximum volume of gas release. How to do? Same like the, I think you know which question, the second or the third question we did earlier in the part 1 video. Go back to the question. You can see the value given. Which set they want? Sorry. They want based on set 2, sorry, experiment 2. So the value given, you see, is for sulfuric acid. They gave me the value of sulfuric acid, but they want to find volume of gas. They gave me this, but want to find this. So what do? The 3 steps, 3 marks, you see? So start from the mole of H2SO4. Mole equals to MV over 1000. One, 2, 0.00254. Then the ratio lah, right? Remember, if you need to write sentence, then write sentence. And lastly, equals to volume over molar volume. And we get 0.06 BM3. That's how you do it. If the change in the mass of magnesium during the reaction is measured, sketch the graph of mass of magnesium against time. Sketching graph, I think for the Selangor paper, sketching graph, this time they might only ask for two types of graph only. It can be a reactant time graph. It can be a product time graph. So you see, they want you to sketch the mass of magnesium. Magnesium, you look at the equation. Magnesium is in the front. Magnesium is reactant. Reactant is 材料。在你做东西的时候，材料会不停的减少。Okay, reactant will always decrease, while the product will increase. Okay, so if it's a reactant time graph, let's say the reactant is mass of magnesium, then we just change it to mass of magnesium. Then the curve is supposed to go down. And then don't forget, for reactant time graph, got two methods. It can be go down straight to the x-axis, or above the x-axis. If it doesn't go to x-axis, means it is in excess. That means it is not finished yet. 我的 mg 还没有用完，它只跌到来这边 haven't used up. If go down to 0 means all used up. So how to know? Go back to the question. Magnesium, you see what they say? Excess. So excess supposed to draw the purple one. Okay, can then if it is product time graph will be this one. Volume of hydrogen gas against time. So how to get the graph pattern like this? Okay, see now the product is volume of hydrogen gas. Wait, what I did on the top, it's supposed to be volume of hydrogen gas. What am I doing? Sorry, it's supposed to be the volume of hydrogen gas. So here, see to sketch product time graph, we must compare the steepness first. That means the rate of reaction. Let's say, I know rate of reaction in experiment 2 is higher than experiment 1. Then when I'm sketching the graph later, 2 has to be steeper than 1. And then height. Because 2 is using sulfuric acid, so double. So the height, the amount of gas released by sulfuric acid will be double. 就是 sulfuric acid 产生的 hydrogen gas 会是2倍. So when I'm sketching my graph this time, I know that I have to draw 2 steeper than 1, 2 higher than 1. 就是这样. First, we simply draw 1 as a standard, and I label it as 1. Now I'm drawing 2 that has to be steeper and higher. Steeper 就要在左边 higher. Okay, because the difference is 2 times, so this is why in the front they label V and 2V. Okay, can So if you want to label the curve 3, you compare it with curve 2 as well. You can see with catalyst, experiment 3 is going to have a higher rate than experiment 2. So 3 has to be steeper than 2. But same height, because they use same acid. Okay, just like that. So this is how I sketch reactant time graph and product time graph. One go down, another go up. Next question. So another 3 sets of experiments. So let's find out what are the factors affecting the rate of reaction. So here, experiment 1 and experiment 2, okay. The difference is concentration. Okay, then for experiment 2 and experiment 3 is catalyst. Oh, okay, so it's like the same thing lah. So they asked me, what is the color of copper 2 sulfate? Blue salt. Copper 2 sulfate, Cu2 plus are blue, except for CuCO3 green, CuO black. Okay. Then referring to experiment 1, 2, 3, state the meaning of rate of reaction. Oh, I want to do this. Okay, this is the one that is important in the tips. When giving rate of reaction, okay, there are two types of definition. It's either you give general definition, which is change in the quantity of reactant or product per unit time. That means the meaning of rate of reaction is quantity over time. That's how we calculate rate of reaction. We use quantity to divide time. Okay, so quantity of reactant or product per time. But for this kind of question, they say based on refers to the experiment. Every time you see the word based on refers to according to the reaction above, we can't just write quantity of reactant or product per unit time. We have to change the keyword. We have to know what is the quantity that we are measuring. So the quantity that we are measuring is also called measurable change. Measurable change of quantity is actually quite simple. For reaction that produces gas, this one produces hydrogen gas. You see, sometimes they show you one. Like they show you, okay, this is the volume of gas collected in a specific time. So you see, this is the quantity, this is the time. So quantity is the volume of the gas law, but we have to mention it clearly. It is the increase in volume of hydrogen gas per unit time. Like that. So the quantity have to change to the specific one according to the experiment. And then two factors that affects the rate of reaction. Concentration of what acid is that? Nitric acid. And then same thing again, like the previous question, presence of the copper 2 sulfate catalyst. Okay, now we are going to sketch the curve obtained from experiment 1 and experiment 3 on the same axis. Okay, experiment, okay, I know what already. Okay, I removed the diagram actually. So now we have to, okay, we sketch 1, 2, 3 together. Okay, 1 and 2. Higher concentration, higher rate of reaction, right? So that means experiment 2 is going to be steeper than, reaction 2 is going to be steeper than experiment 1. And then the amount of product, this time they use the same acid, but does it mean they produce the same amount of product? No, because the amount of gas release can be predicted by using the number of mole of the reactant. That means 你在做东西的时候，你在做那些做食物的时候，材料会决定它的产量，材料越多，它就可以生产越多那个它修出来。所以在这边 the number of mole if you calculate the number of mole, the acid here is 0.00254. MV over 1000, 0.0054. So you can see more reacted, it will result in a higher amount of product. So 2 has to be higher than 1 as well. So let me draw it out first. Draw a simple one. And then 2 is higher. 2 is higher and also steeper than 1. And then you can see they are also very good. They even give you the volume of gas here, 300 and 600. So since they are given, we have to label it. So this one will be 300, 600. And then for experiment 3, when I compare it to 2, their number of mole is the same. You see the volume same. So height will be the same, but then with catalyst, the reaction will be higher. So steeper, but same height. Like that. So this is experiment 3, 2, 1. And then because time is also given, time taken to complete the reaction, 30 seconds, 40 seconds, 30 seconds. Okay, then we have to go like this. 30 seconds, that means we have to end earlier a bit here. Sorry for this one. Almost the same as the reaction 3. So 30 seconds, 30 seconds. 1 and 3 is 30 seconds. And then number 4 is 40 seconds. Like that. Okay, just like that. Normally, when they mark your curve, right, they check steepness and height. So like just now, if this one is like a bit too front, it's okay, right? Okay. Because sometimes they don't give you the time or this, you do not know where is it, it's okay. Just simply sketch. As long as your steepness correct, height correct, then can already. Okay, next. Then calculate the rate of reaction for experiment 2 and 3. To calculate rate of reaction, quantity over time. Okay, quantity over time. For experiment 2 is 600 cm cube over time 30 seconds, 40 seconds. So 600 divided by 40, I get 15 cm cube per second. As for experiment 3, this one, 600 cm cube divide 30 seconds. I get 20 cm cube per second. Just like that. So must know how to calculate rate of reaction. Next, Okay, here is another experiment. It is between zinc and sulfuric acid. So this one has catalyst. Okay. Meaning of catalyst, I put the definition here already. Because I don't think it's going to come up. This one. So I'm going to do this one. Sketch a graph of volume of gas against time for both set of the experiment on the same axis. Experiment 1 and 2, let's compare the rate of reaction. This one has catalyst. So 2 is going to have a higher rate of reaction than 1. So 2 will be steeper than 1. Okay, 2 will be steeper than 1. And then height. For height, right? This one you have to be careful a bit. Sometimes, right, they will give you time and volume of the gas, but that is not the complete reaction yet. 就是它给你的时间跟那个 amount 哦，并不是全部，它只是到中间的时候它记录起来吧。So this might be the time they recorded before the end of the experiment, okay? But what we have to do, what we have to do is we have to look at the experiment lah. They use the same acid. The only thing that's different is catalyst. When you use catalyst in a reaction, the catalyst can only make it faster, but catalyst cannot cause it to produce more products. Catalyst 只能够让它变快，可是它没有办法让它产生更多。Because the amount of product is decided by the amount of reactant you have. Since the reactant is the same, then they will produce the same amount of the product. Okay, 希望你可以明白这个东西。This one might not be the full amount yet. Okay, it can be like the halfway, like maybe they take the halfway one, like this, this one, this point. Okay, so yeah. So when I'm sketching the graph, 2 has to be steeper than 1, but same height. Two steeper, but same height. Okay, volume of hydrogen gas, cm cube, time per second. Calculate the average rate of reaction for the first 3 minutes in set 1 and set 2. So again, calculate average rate of reaction, quantity over time. 40 is quantity, divide by 3 minutes. If they give you minute, you use minute. If they give you second, you use second. Unless they say, oh, I want second, then you have to convert it. But if you want to convert, also can. But normally I don't convert. 40 divided by 3. Oh, sorry, the curve I label second already, I convert lah. 40 divided by 3 times 60. That means 180. I get 0.222 cm cube per second. At least 3 decimal places for reaction 1. Reaction 2, 50 divided 180. 0.278. Like that. Compare the average rate of reaction. So the average rate of reaction in set 2 is higher than set 1. The way of how you know this answer is by looking at the question. One got use catalyst, another no catalyst. Or you can look at the value. The bigger the value means the higher the rate of reaction. Lastly, explain how catalysts affect the rate of reaction. When they ask how it affects, then we will talk about, we will discuss, we will write the answer in the form of like how it changes, 它改变. If they want me to compare all the points, I will write in comparison form. So catalysts provide, and this is collision theory. That means you have to memorize what the one we just did in last month. Catalysts provide an alternative pathway with lower activation energy. Okay, in this experiment, they are using zinc. So I will write zinc atoms and hydrogen ions. Okay, we just finished this chapter last month. So I hope you still remember how to do. More zinc atoms and hydrogen ions can achieve the lower activation energy. This is very important. Without writing this correctly, your answer will be wrong. This is from the ionic equation. If you don't know how to write ionic equation, you can watch the another YouTube video in my channel. You just find it. I put in the playlist for you. It's about how to write ionic equation. This is from the ionic equation. Then lastly, frequency of effective collision between zinc atoms and hydrogen ions increases or become higher. Okay, next. Question 7, chapter 8. So the diagram shows a medal made of bronze. Name the element added to copper to form bronze. Element that's added into copper to make bronze is tin. Okay, if it is brass, then it will be copper plus zinc. Draw the arrangement of atom in bronze. Okay, remember, when we are drawing the arrangement of atom in alloy, I will usually draw two big atoms and then followed by small atoms around it. Don't overlap. Also try to draw as good as possible. Okay. So they all will be in the same size. Okay, like that I copy paste faster. I will draw a round of smaller atoms around. I will draw the smaller atoms around it. If no space is okay, you just put it like that. Because the arrangement is supposed to be a bit messy. Then you just fill up, fill out the space. Then this one put another round also. like that. Okay, then fill up some of the space here. Like that, then can already. When we labeling, whenever we are labeling it, you have to label it. We don't label based on the size, we label based on the amount. Bronze is mainly made of copper, so a lot of copper with a little bit of tin. That's how we decide it. Okay, next. Why is bronze more suitable for making medals compared to copper? Okay, why we use bronze instead of copper? That means every time when they ask you why you choose bronze, I mean why you choose alloy, because I can say bronze is harder and stronger than copper. I can say bronze has a better appearance. Better appearance usually means it has shiny surface， 它的表面是光滑很亮。I can also say it has higher resistance. To corrosion. So that means it doesn't rust easily. So one of it. Name another alloy of copper. Brass. Brass and bronze are the two most commonly come up question lah. Okay, for alloy. Next. Shows the arrangement of atom in pure copper and alloy Y. Name atom X. So up to you lah. Alloy Y, you want to make it a tin or zinc. Up to you. If you put tin, then it is bronze. If you put zinc, it will be brass. Explain why alloy Y is harder than its pure metal part. They always like to ask you, why is it harder? Remember to mention these 3 points. First, because of the size. So I can say the size of atom X is different from copper atom. So these atoms, they are added into the copper. They are in different size. Like we mentioned in the class this week, size. 要讲到 size。第二，我们要讲到 orderly arrangement of copper atoms is disrupted. 所以原本排美美的这个 copper 它的顺序被打乱了。They are arranged nicely, but then it is disrupted. That means now it becomes very messy, not orderly arranged anymore. And lastly, we got to say, say what? Okay, the layers of atom. They do not slide over one another easily. So that means they are harder to move around now. Size, orderly arrangement disrupted, are hard to slide. Okay, then next, we have glass here. State the main component of glass. So glass is mainly made of sand, but we can only write silicon dioxide or silica also can. 玻璃主要是用砂来做，不可以写砂，一定要写这个 silicon dioxide. Then state one reason why borosilicate is most suitable to be used to make lead glassware. borosilicate. So the special property of borosilicate glass is it withstands wide range of temperature change. Don't write answer like high melting point, because all the glass they have high melting point. But this one, it can tahan different type of temperature, very cold or very hot also can, and it doesn't break. So this is the special part about borosilicate glass. And then next, my God, still got so much. I'll go through everything. Okay, question 8 about salt. Salt. Okay. From the tips, it says it mostly will be preparation of salt. It is a reaction between acid plus metal, it says. Okay, so maybe they will give you HCl plus zinc to get zinc chloride plus H2, something like that. Now you see, acid plus metal, acid plus metal. So you have to know this kind of method is for which kind of salt. Okay, so if you forgot already, you can watch one of my video also in the playlist. Is about salt one. It revises like almost everything about salt. So preparation of salt got 3 cross. OHH, COOHH, and N star. These cross are used to find, the purpose of the cross is to find reactants 十字架是用来找材料的。Okay, how to know which cross to be used? 用什么 cross 呢？ So first you have to ask yourself, is the salt soluble or not soluble? If it is insoluble, we use this cross. Soluble, we use the 2 on the left. And then you have to see whether the soluble salt has spar or not. Got spar, OHH. No spar, COOHH. So when you look at this diagram, we can tell that they are doing this non-spar soluble salt. Because spar soluble salt uses titration method. That means the one with burette, they drop the acid into the alkali one. But this one is not, so it will be the second one. And then this one, you add 2 solutions together to get precipitate. Precipitate must be insoluble. So the way of how to use it is, if you want to make CuSO4, you put the salt ion here. This is the salt you want to make. And then you pair it with the ions on the top. COOH can be carbonate. It can be oxide. It can be hydroxide. And then react with the acid. Like that. So from the given example, identify the salt that can be prepared by using the methods as shown in diagram 8.1. Diagram 8.1, what's that? Okay, method 1 and method 2. So we have to cluster into method 1 and method 2. So first, you just have to know whether it is soluble or not. Barium sulfate, insoluble. Nitrate, soluble. Magnesium chloride, soluble. So the method will be 2-1-1. This is the first method, second method. And then we are going to speak the reactant for the preparation of salt in method 2. So method 2 is this one. This one. They want the reactant. So see how I do. I know that it is insoluble salt. I got to use the N star cross. BaSO4. BaNO32 plus potassium K2SO4. These are the reactants. If you complete the equation, you are going to get the salt. So this is the salt that you want. So eventually you will get back what you put into the cross. Just like that. 用对十字架就可以找到那个salt 这样的。So what if the question asks method 1? Method 1 is this two 这两个Okay, let me do the cross COOHH with magnesium chloride. So it can be magnesium carbonate, magnesium oxide, magnesium hydroxide. Actually, for reactive metal that are reactive, like what we mentioned in the empirical formula just now, magnesium, zinc, all these reactive metal, we can actually use the metal directly to react with the acid one. But for another one on the top, copper 2 nitrate, copper is a weak metal, right? Just now we already said in the empirical formula. The girlfriend got stolen away, it is weak. For weak metal, it can only use COOH, but not the metal itself. Why? Because it is less reactive. Remember, so for making salt, since the question says they are going to ask you acid plus metal, be very careful. If they want you to suggest a salt, I think they will ask you to suggest a salt. So you have to remember like one of the example, like magnesium sulfate. Up to you, magnesium chloride, magnesium sulfate, magnesium nitrate also can. I think okay, they will tell you that okay, you have a metal Mg and then react with a strong acid to get a salt. So the strong acid HCl, then MgCl2 plus H2. Okay. So here will be HNO3. Just like that. Now move on to the question 8b. So this whole page is mainly telling you how to find the reactant by using the 3 cross. Okay, then now in this question 8b, it's in BM. So copper 2 oxide plus acid X. So metal oxide plus acid is this one, COOHH. And can you see they are not titration? 它不是那个 titration 的。So what kind of acid X will get you in the end the copper 2 sulfate solution? So you see 我要做到的 salt 是 CuSO4。我要找到材料 acid X 是我的材料。I already have CuO. So all I need now is the sulfuric acid. Okay, and then explain why acid X has to be heated. We will heat this acid. It is to increase the rate of reaction and so that the copper 2 oxide can dissolve better. To increase the rate of copper 2 oxide dissolved into the acid. Okay, then cadangkan satu bahan lain yang boleh digunakan untuk menggantikan cuprum duoxide. So they say other than CuO, what can be used to replace it? As we say, CO is carbonate, you can use copper 2 carbonate. You can use copper 2 carbonate. You can use copper 2 hydroxide. Can use the metal itself or not? Cannot, because less reactive. Okay, then anion test. Ujian anion. Anion is negative ion. In the copper 2 sulfate solution, they want to test the sulfate ion. This one we also done it in the class already. It's something that you have to memorize. So I'm not going to do anything here. You just memorize for sulfate. And then if they want you to test for chloride, you will do the same thing. I write the exact same sentence, but here you use silver nitrate solution instead. Then the observation is the same one. It's also white precipitate. Just change the solution only. For sulfate, we use barium, silbao, right? And then chloride, we use roti canai. Like we say in the class. Okay. Next. All this must write. Everything must write. Memorize only. The other part, you see, they add two solutions together, and then they get insoluble precipitate. Can you see? What kind of reaction is this? As long as they are preparing insoluble salt, it will be called double decomposition reaction. Chemical equation. Okay, chemical equation. Chemical equation. This one is CuSO4 plus Na2CO. I mean Na2CO3 to get CuCO3 plus Na2SO4. This is the insoluble salt. Okay. Then if they ask you to write ionic equation, if it is ionic equation for insoluble salt, very easy one. Shortcut. I say shortcut. I go shortcut. If you want to find the complete method, watch the YouTube video in my channel. I don't know where. I mean, like you find out, okay. I think it's in the playlist one. CuCO3, the insoluble salt must be insoluble. Only can use this shortcut. 一定要是 insoluble 才可以用这个 shortcut Cu2 plus CO3 2 minus。你把它的两个 ion 写出来 ，the two ions put it there. Okay, then the Hubler Y, the salt crystal Y. What is process Q? Okay, this is basically filter, rinse, and finally dry. It is the drying process actually. Okay, for those who are having the procedure questions, please read the experiment. Question 8C. Ooh. Okay, C. Okay, first, we do know all these things. Okay, but we know PbCO3 whenever it is being heated, when a salt is being heated, 当一个 salt 被加热的时候，它会分解，它会 decompose into a metal oxide and gas. Okay? So they are asking me like, hey, what should be the T? You see, they want me to find the reactant. This is one of the reactant to produce PbCO3. So what I can do is I use the cross. Then I know that this is lead to nitrate. When lead to nitrate being heated, it produces metal oxide PbO. Can you see? Same. NO3 will produce NO2, which is brown, and O2 that is colorless. The name of PbO is lead 2 oxide 没有 two 就错了的啦 must have two And then the name of NO2 is nitrogen dioxide gas just like that. You just list out all the things with their name, they can already. And then they say T, lead 2 nitrate is a white salt. Describe a chemical test to verify the N ions present in the salt. They want to test nitrate ion. Just now is sulfate and chloride. Now is nitrate. Same lah. Memorize. Next. Question 9. What is that? A state. Chemical bond. Okay. In the question earlier on, we mentioned that they are ionic and covalent. You see this one got ion, ionic. And then you see they share electron together, covalent. And then what are all the other bonds like hydrogen bond, dative bond, metallic bond? I will mention one by one. I list down here. Ionic, as we say, is metal atom plus non-metal atom. Atom is one. It's like the Na with Cl. Donate one electron to the Cl behind NaCl. This ionic. Covalent is non-metal atom plus non-metal atoms. For example, carbon and oxygen, they share electron to become carbon dioxide. And then hydrogen bond. What's hydrogen bond? Hydrogen bond, I call it as handphone bond. I think I'm the only one who call it handphone bond. the rest of them who say handphone bond must copy me on it. So handphone bond, what is handphone bond? According to the definition, it says in order for hydrogen bond to be formed, you need at least two molecules. It must involve at least two molecules. Now you see the difference or not? These are atoms. Atoms mean they are not stable one. So this one, they donate or receive electron to become stable. This one, they share electron to become stable. Hydrogen is a stable molecule. Why I call it as handphone bond, H-phone. So the molecule one must has its own handphone. I don't care whether you use iPhone, you use Samsung, or maybe you use Oppo, okay, as long as you have one of it. So molecule have, let's say molecule one has this one. Then molecule two has the HO. Then they can form hydrogen bond with one another. By the way, hydrogen bond is actually a force of attraction. So it's a force of attraction between two molecules. So attract together. Okay. Then another one, dative bond. Dative bond is a bond formed between a stable molecule. That means that it's already stable. It doesn't have to donate, receive or share anymore. And then this stable molecule, because it is already stable. Let's say I have a stable life, okay, I donate some of my money to help others. So the stable molecule will share the extra electron with others who need it. So when a stable molecule share electron with an unstable substance, it can be an atom, it can be ion, it can be molecule, whatever. As long as stable, unstable, dative. None of the above is this pattern. You see this one? Not stable, transfer. Not stable, share. And they are atom. This one is molecule already stable, then they have extra connection. This one is stable, not stable, okay, I help you. Dative. Last one. Metallic bond. Metallic bond only happens in the metal structure itself. Let's say Fe. It is atom only. No friends one. It can be sodium. It can be magnesium. Alone is metallic. You give yourself a hug. This is called metallic bond. All right. So now electron atom magnesium. They want the electron arrangement of magnesium atom. You see, this is ion. Ion is already stable one, but atom is the original one. 2 plus means it has donated 2 electrons. So this is 2A. So before donate electron is 2A2. Jenis ikatan terbentuk antara magnesium dengan oksigen. This is ikatan ion, ionic bond. Jenis ikatan yang terbentuk antara nitrogen dan hydrogen dalam ammonia. So these are between hydrogen and nitrogen. You see, this is like just not stable atom, share electron, right? Covalent. And then it says ammonia can dissolve in water. Mean the type of bond. Ammonia is a molecule, a stable molecule. Water is also a stable molecule. And then in the molecule, they have their own handphone. This is HN. This one is HO. Got handphone, then they can call. This hydrogen bond. Jenis ikatan hydrogen bond. How to write the formation of bond? You see, what I say is ammonia has handphone. The hydrogen is bonded to nitrogen, HN. Then they can connect to one another. Same lah, memorize. Okay, then at the bottom one, we have ammonia, a stable molecule that want to combine with hydrogen ion. Hydrogen ion is something that doesn't have any electron. So it want to share electron with the other. This is dative bond. Okay. And then this one, very important, assay. When they show you an experiment, something like this, lead 2 bromide, okay, it is solid. When it is in solid, bulb does not light up. Bulb no lights up means cannot conduct electricity. Bulb lights up, can conduct electricity. So that means solid cannot conduct, molten can conduct. Naphthalene, both also cannot conduct. So they want you to explain it. Why like that? These are the explanation, which I'm not going to go through any of it. You just read it and memorize it yourself. So basically, lead 2 bromide is an ionic compound. And naphthalene is a covalent compound. You can write it in sentence form. In exam, you want to make a table also can. You can make a table, but then don't put the point form like that. I put the point form like that is for you easier to study only. Okay, so that you know which one got marks, which one doesn't have mark like that. And I know this here got definitely more than 10 points already, but normally when we do essay, 1 or 2 points, a few points extra is okay lah. Don't worry. Okay, read yourself. Then here, question 10 is about acid and salt, I think. So one of the question is about role of water. Okay, let me explain something. For acid and base, normally they have these few types of questions. What for explanation question, got 3. Role of water. Role of water means got water, no water. What's the difference? Got water, then can ionize. No water cannot ionize. Can ionize, got property. Cannot ionize, then no property. This is called role of water. And usually in role of water question, they will ask you for solvent. Okay, later I will explain this. And then number 2, it is the pH value and concentration one. They always like to ask you like, hey, how come this acid A higher pH value? pH B, acid B lower pH value. When they want you to compare the pH value, usually they are about strength of acid or alkaline. That means you have to explain by using strong acid, weak acid, like that. And then the last type of explanation question is basicity. yeah. Basicity of acid. That means the mono and diprotic one. Yeah, like the one we do in rate of reaction just now. Monoprotic, diprotic. Okay, these are the explanation question. And then for calculation question, usually we have neutralization. The MAVA over MBVB equals to A over B, that one. Must know how to use the formula. And then we also have dilution, which is M1V1 equals to M2V2. And also calculate pH value. So 3 lah. So when we look at this question, they say they want to study the properties of alkaline. Solvent P, sodium hydroxide. Color of red litmus paper does not change. So you see, they are telling you that this one got no property with solvent P. Red litmus paper turns blue, got property with solvent Q. Every time you see solvent question, just remember these two types. Solvent is either water or organic solvent. The one that has reaction must be water, because water can ionize the alkali or acid. Then the other one will be organic solvent. You have to name one example of organic solvent. You can't just write organic solvent. It can be tetrachloromethane. It can be okay, my favorite lah, methylbenzene. This kind of weird name, tetrachloromethane, methylbenzene, propanol, they are organic solvent. So you just remember one. When you see solvent, you just write these two answers only. You see, when I use organic solvent, the sodium hydroxide cannot ionize without water. So there is no hydrogen ion to show alkaline property. So there are other ways they can set this question. If they doesn't want to give you the litmus paper, there are a few other patterns. If they don't want to give litmus paper to show property, they can use reaction. That means one beaker got reaction, got bubbles. Another one don't have bubbles. So that you know, which one is water, which one is organic solvent. They can also use electrical conductivity. So that means like that, they can do something like that. Okay, let's say that 3, let's say light bulbs. Okay, it goes like acid in solvent A, like that. Bulb lights up. Okay, solvent A is water, but reaction, you find it. If the same thing, but no lights up, then organic solvent. Okay, and then here, a student added the hydrochloric acid into sodium hydroxide. You see, what is this? Acid added into alkali solution. Neutralization. Calculate the concentration of sodium hydroxide. This is your MA. This is your VA. This is your BB. First, we must write an equation because we need the ratio. MA, VA, MB. That is what they want me to find. Concentration of sodium hydroxide, MB. VB equals to ratio. What's the ratio? 1, 1. 1 acid, 1 base. Then you get 0.0125 mole per dm cube. And then determine the pH value of sodium hydroxide solution. So to calculate pH, we have 3 formula. pH equals to negative log H plus. POH equals to negative log OH minus. And pH plus POH equals to 14. So when they want me to find pH, of course I will need this formula, right? Because I want to find pH. Is it like that? No. You have to base totally, it is based on the chemical substance given. The H plus and OH minus refers to the ion. You look at this solution, got H plus or not? No. So there's no way you can use pH equals to negative log H plus. So what I can do here is I will be using this POH instead. So I can sub it into the OH minus here. So POH is equals to negative log. This is the concentration of hydroxide ion. Now the concentration you got just now. 0.0125. Press your calculator, negative log 0.0125. We get POH 1.9. Yeah. Then how to find pH? When you want to convert POH into pH, you sub it in. That means you move it to the other way and cut off. I mean, and minus lah. So the answer is pH 12.1. Like that. Okay, so let me mention, wait, let me see. Okay, let me mention another example. Let's say it is H2SO4. When you want to find the pH, right? When you sub the number, let's say it is 0.1 mole per dm cube. Concentration, you don't just sub 0.1 for H2SO4. Because concentration of hydrogen ion got double, then this one you have to times 2. Okay, next. So this question shows you a different pH value, but they are both monoprotic acid. Suggest the name of acid A and B. Like I told you, usually pH value different. They will be strong and weak. So this is strong hydrochloric acid, weak acid, ethanoic acid. Okay, then why the two solution has different pH value? Okay, because hydrochloride is strong, ionized completely, produce higher concentration of hydrogen ion. Electrolysis is weak, partially lower concentration of hydrogen ion. And then one more point. The higher the concentration of hydrogen ion, the lower the pH value. And then calculate the molarity of acid A. Acid A, pH 1, right? From the question just now, from pH, you want to find back the concentration. Okay, pH is 1.0. Now we want to find the H plus. So in maths that you have learned will be anti-log. Okay, log, you put it to the other side will be anti-log. So anti-log is 10 to the power of. You just press your calculator, anti-log. And shift log. You press your calculator, shift log. You will be able to get this. And then minus 1. Minus 1 is equal to H plus. Then H plus is equal to 0.1 mole per dm cube. So shift log -1. Yeah, correct. Just like that. 10C is a titration. So for titration, I want to go through the indicator a bit. Indicator that can be used titration can be phenolphthalein or methyl orange. Color change, phenolphthalein it turns from pink to colorless. Methyl orange from yellow to orange. Type of reaction, neutralization. And by the way, neutralization is also the reaction to produce soluble salt. Most of the soluble salt, we use neutralization to make. If it is insoluble salt, double decomposition reaction. Equation for this one, I skip because the same as the one I did just now. This one here. You can try to calculate yourself. You should be able to get the answer 31.25 cm cube. Okay, and then please be very careful when they use sulfuric acid. Because when they use sulfuric acid, the ratio will be different now. The ratio, the A over B. You just write the equation, then you will see. The A over B here will be different. It will become 1 over 2. Very tired already. Okay, then all these questions left are rate of reaction. Similar to the question in front. Similar to the question in front, which I don't want to do already. This one, I got all the collision theory here. I will post this answer in the Google Classroom as well. Okay, I have all these answer. Okay, for you now. Okay, I show you the question now. Okay, now question. Then this one, collision theory. Then this one got question. If you do the calculation, you are going to get 600 cm3. Then collision theory. This one I do this only because the other one is in the previous question. Okay, last. Hydrogen peroxide is an unstable substance. It decomposes to form water and oxygen gas. Let me write the equation out. Hydrogen peroxide is also in rate of reaction. Catalyst used in hydrogen peroxide is manganese oxide. How catalysts affect the rate of reaction? We done it earlier on already. Okay, then last part. Energy profile diagram. When you see energy profile diagram, you've got to draw something like this. If you want to ask me, hey, how do I know whether it's endo or exo? It's always like that, from higher to lower in the syllabus lah. Always higher to lower. For now, you don't have to worry. Just always go from top to the bottom. Then put the equation on the horizontal line. And then wait, okay, the activation energy is in this mountain lah, okay? The height of this mountain is activation energy. So they want me to label activation energy without catalyst with EA, and catalyst is EA prime. So without adding catalyst EA, like that, you can label it inside. You can also label it outside. So up to you, inside or outside. I think one outside, one inside looks nicer lah. Okay, then draw the second one. This is the one with catalyst. With catalyst, the activation energy becomes lower. And this will be the one with catalyst, lower EA prime. Like this. Remember the label energy, equation, EA prime. That's all. Good luck in your exam, and hopefully all these things come.